Hello, and thank you for taking the time to attend our Healthcare and Life Sciences webinar titled Enabling Agile Development and Infrastructure Scalability under HIPAA Compliance. This webinar is presented by UCSF, AWS, and ClearScale, who is an AWS Premier Consulting Partner. My name is Jimmy Chu. I am the Director of Customer Success at ClearScale. So for our agenda today, I will introduce our speakers, Sandeep from UCSF and James from AWS. Sandeep will talk about the opportunities and technology demands from the UCSF perspective and their decision to embark on the public cloud journey. James will cover the AWS Landing Zone concept and how its features align with healthcare and life sciences implementation. And then I will talk about the engagement with UCSF with ClearScale to deliver a landing zone based solution that provides the compliance, the scale, and agility for UCSF. And then we'll open it up for a Q&A. And again, we encourage you to post your questions in the Q&A tab throughout the presentation as those questions arise. So Sandeep Giri, he is the program manager at UCSF in the School of Medicine Technology Services, SOMTech. He's been working with all of the teams over there around new research, clinical applications, and the secure cloud environments, and scaling out their high performance computing platform. So he's got a lot of experience. He's in touch with the new demands and new opportunities that are arising at UCSF. And we have James Wiggins. He's a senior solutions architect with AWS. He works in the academic medical space, lots of universities affiliated with hospital systems, schools of medicine, and organizations that perform medical research. And he helps them to leverage the AWS cloud securely to protect their PHI information. And then myself and Jimmy Chu, the Director of Customer Success at ClearScale. I've been in the IT space for over 20 years, and currently I assist a broad range of customers in all verticals to adopt cloud services. And I'm going to hand off the presentation over to Sandeep, and he's going to introduce you to UCSF.
Thanks, Jimmy. UCSF is, oops, one more, is one of the top academic medical centers in the country. There's 19 PhD programs, 11 master's programs, and about 6,000 students, residents, postdocs, over 3,000 faculty, including many Nobel laureates. And we have about 24,000 general employees. So it's a pretty big institution. I work in a smaller group, School of Medicine's Technology Services Group to be particular, also called SOMTech. We provide technology consulting services to both researchers and clinics to design and develop different types of digital projects, including the one that need to be deployed on the cloud. So I am going to share some of the key opportunities and demands that we see in healthcare and life sciences today, and a little bit of our own attempts to address those opportunities and demands, specifically in the role of cloud computing in this process. So first off, there's an explosion of data. Not sure if it's because storage is cheap or we're just getting really good at tracking just about everything, but it's growing like crazy. And healthcare in particular is notorious for creating huge data sets that are unique to just healthcare, particularly with imaging and genomics data. The other area of big growth is data science. Here are some sample research projects that are ongoing at our Baker Computational Health Sciences Institute. And you notice I've just underlined or circled, like almost every topic is heavily vested in data science. We have researchers training algorithms on how to read CT scans like an ER surgeon, where there's a project that's de-identifying the entire patient data set from EHR, imaging, notes, all the works, and making it available for research. I was just recently literally grilled by a researcher for lumping artificial intelligence, machine learning, and deep learning in the same category. I'm still a little vague on the nuances, but suffice to say, data science is all over UCSF. And so in this situation, first off, sorry, we need a lot of storage for our research work. So here's a projection made by CDW that says healthcare industry will need about 25,000 petabytes by 2020. And I believe it. Just last month, we did a call with our researchers to order new storage for their upcoming projects. And literally in about a week's time, the total request, it totaled about 1.5 petabytes. So 25,000 is not that far. And researchers also need a lot of compute power, both CPUs and GPUs. Now that AI and ML algorithms are all in the vogue, they're hungry for parallel processing, which I'm sure makes hardware vendors very happy, but this is our reality. But our core business as an academic health center is not hardware or infrastructure for that matter. There are really two key business problems we face, and both of these desperately need agile development and infrastructure scalability. The first one is to develop clinical apps that add functionality to EHR, which is short for electronic health records like Epic and Cerner. The second is the heavy-duty research computing projects that also need to work with very sensitive patient data. So let's dig a little bit more in this. Like every large medical center, we have made a huge multi-million-dollar investments in EHRs that took years to implement. While these systems are really great for record keeping, they haven't proven to be so good at managing day-to-day workflows. So much so that during a patient visit, doctors are spending up to 2/3 of the time looking at their computers, punching data into EHR systems instead of making eye contact with the patient. And physician burnout because of record-keeping burdens has sadly become very common. And so in an attempt to address this, there's a glut of digital health apps that are being developed, both internally within health systems and also by commercial vendors. And EHR vendors are now working to make these apps available in an app store-like model. These apps mainly help with specific aspects of workflows, like electronic self-registration or check-in instead of filling out a clipboard form, enabling referrals from PCPs to specialists, using natural language processing to take notes and enter data during a patient visit so that the physician is freed up a little bit, automating post-visit follow-ups to ensure medications being taken as prescribed or that patients are on track with their physical therapy, diet, or dressing up their wounds and what have you. And on the research computing side, the demand is also soaring. Here are some key institutes within UCSF: Baker Institute, Cancer Center, Human Genomics, Resource for Biocomputing Visualization and Informatics, or RBVI for short. And then we also have a project called Winton, that's our HPC cluster, first designed for basic research computing and now expanding to enable secure computing with sensitive data. And all of these getting more and more hungry for processing power and storage. So now when there is whether it's a new clinical app or a new groundbreaking research computing project, we need to be able to develop and deploy it very, very quickly, which we find almost impossible to do because of our process that's shown in this flowchart, which I'm only half joking because you see, healthcare is very, very conservative and for a very good reason. You don't want us to be just taking your medical records very lightly. So we have layers and layers of both physical and logical security, layers and layers of governance processes to make sure we greatly minimize, if not completely eliminate, any potential harm to your medical records. So if you want to deploy new software that is going to change the existing infrastructure or systems, even in the slightest way, you still have to jump through all these hoops. Reviews with technical and governance committees, paperwork, to a point where we now estimate a new project, we almost put as much time to clear the governance process as much as we put for developing and testing the software itself. So as demand for storage, compute, and new clinical apps and research computing apps grow, we hit all these constraints. Our data centers have physical constraints, procurement and provisioning takes long, And taking each project through this laborious, complex series of security approval and other tasks is just not scalable. That's our challenge. So we then started looking at the cloud. I mean, we threw our arms up in the air and pointed our eyes to the sky and looking at the cloud. And here's what we realized. One approach we took, and we started with the research computing use case first, was to look at AWS and consider something that we call AWS Research Cloud, or ARC for short. The idea was that any researchers at the UCSF should be able to run their research computing project on AWS, utilizing the same BAA, which is the Business Associate Agreement between UCSF and the AWS, so that a separate BAA doesn't have to be done for each project. We then wanted to have a common security and compliance monitoring done for all the research projects so that each new project doesn't have to build their security and compliance infrastructure separately. So the goal was to have a single multi-tenant platform with a common security and compliance layer, while giving each research project its own secure sandbox within AWS so that they can conduct their research computing utilizing all of AWS's HIPAA compliant services and not have to worry about all the security and compliance related infrastructure stuff for each project repeatedly. And so as we embarked on this journey to start working in this environment, we had some very basic concerns. So first off, for the developers who are working on research projects, how do we minimize their learning and while still meet our security and compliance threshold? Second, what particular design frameworks and tools within AWS that we should use and rely on so that it's possible for us to provide this common governance and oversight across all projects and protect sensitive data while still enabling the independent sandboxes to run independently for each research project. And lastly, how do we fit all this into our existing governance processes and especially meet the requirements of very high thresholds set by our own IT departments to protect our data. So to address this, we turned to AWS and ClearScale to partner with us in helping us design a solution. And our next speakers will walk you through the details of that process. So I'd like to invite James Wiggins from AWS to talk about the various tools and strategies available within AWS to address these type of concerns. So James?
Yeah, thanks, Sandeep. Yeah, exactly like you mentioned, as customers are coming to the cloud, particularly enterprise customers in healthcare, there are a lot of concerns about how do we retain our existing governance standards and processes as we move to the cloud, and how do we ensure data security? How do we meet the regulatory requirements of managing PHI in the cloud? And so AWS is working really with customers in ostensibly every industry, but particularly in healthcare. We're really diving deep with customers, and I work with academic medical centers in particular, but in healthcare, we're really working across the industry. So with higher education institutions and academic medical centers like UCSF, also working with commercial healthcare organizations like Johnson & Johnson and Cerner, working with government organizations in healthcare like the CDC and the FDA, or nonprofit institutions like the American Heart Association. And really aggregating those lessons learned and interests from across healthcare from all of these organizations, both domestic and international, and building our services in cloud to meet the needs of healthcare customers. And some of the ways that we're doing that are, we have customers that are working in areas like DevOps and enterprise application development for healthcare applications. We have a lot of tools in that space for Agile development using DevOps principles for healthcare applications. Also in research, I work with a lot of customers, like you mentioned, that have research workloads, and healthcare research is really driving a lot of cloud utilization for exactly the reasons that you mentioned, Sandeep. Just the explosion of healthcare data that really requires cloud scale storage and compute if we're going to be able to perform all of the healthcare studies that organizations want to perform. You got petabytes and petabytes of data, and you need to scale up to, sometimes millions of CPUs in order to do this computation, in order to train these machine learning models. So working with customers to help them use genomic sequencing tools like Cromwell or Nextflow to build genomic pipelines, or to use Hail with our Elastic MapReduce service, our managed Hadoop service to do genomic tertiary analysis, or to get a RedCap environment up and running quickly. We've got a quick start for RedCap where you can get an environment up and running in just 20 minutes. It's fully automated. Using machine learning services like Amazon Comprehensive Medical, which is our new natural language processing service for unstructured healthcare text. It can help customers to extract medical entities and relationships from medical notes. We're also working with pharma and biotech, so customers who need to build out, as you mentioned, HPC, high performance computing clusters in the cloud, and scale up to millions of CPUs to do computation using real world evidence tools like Odyssey and the OMOP Common Data Model, or collect streaming data from manufacturing sensors in the pharma space. We're working with those customers to help provide organizations archive and de-identify PHI, whether that's in images or whether that's from electronic health record data, build machine learning models to do prediction and classification of machine learning images. I work with customers to do that, to do prediction of patient health outcomes, to run their electronic health record systems, and then also to use just common vendor software in the provider space, like Enforce Cloud Suite for healthcare that's built on top of AWS that help them manage their organization's operations. And so, we're working across healthcare with customers in all of these segments in order to perform these different workloads. And what's common to all of these organizations, particularly in the US, is the requirement of HIPAA, and then just the general requirement of security and governance. Like you mentioned, large healthcare organizations, large enterprise organizations have a lot of established processes and governance and security standards, and also regulatory requirements that they have to meet. So like you mentioned, the common question among them all is, as we move to the cloud into AWS, how do we meet those same requirements? And AWS handles security and compliance in what we call a shared responsibility model. So AWS delivers a secure cloud that's eligible to meet standards like HIPAA. And we're taking responsibility of the physical and administrative safeguards of the cloud and then providing those services to customers. And we partner with customers, and they take the shared responsibility of using that cloud in a way, configuring their cloud, their private cloud environment in a way that conforms to their organization's own processes, their own security best practices, and making sure that they're applying the requirements of the regulations they need to adhere to, like HIPAA. And obviously that's where partners like ClearScale are integral to that process, and also AWS providing guidance in the form of a HIPAA white paper that gives an overview of how to apply those controls to our AWS services, and also a HIPAA quick start that helps customers to quickly get started with a HIPAA environment and provide a controls mapping from the HIPAA controls to AWS configuration. So providing guidance to customers around that, but ultimately letting them custom configure their private cloud environment in a way that meets their organization's processes and best practices and governance. And one of the best ways to do that for customers is to use the automation, the management and automation tools that AWS makes available in our cloud. That's one of the most powerful features of AWS, is the level of automation that we provide and the level of governance and oversight. And an important part of that is a solution, a pattern that we launched last fall called AWS Landing Zone. And really what this was designed to address is, in large enterprise organizations, you'll have customers that may have hundreds or even thousands of individual AWS accounts. And they want to be able to manage them and look across them and govern them centrally. They've got a central security organizations, central organizational processes. They want to manage cost in a central way. They want to have a repeatable process for vending new AWS accounts, whether those are for research or applications development. And so Landing Zone is really, again, going back to that, to automation. It's a way of automating the provisioning of new AWS accounts so that you can consistently provision new AWS accounts in the same way, and make sure that the security and governance controls that your organization needs to adhere to are consistently applied, and then aggregate information from those accounts up into central repositories so that your organization's teams, security and compliance teams, can look across it and understand what's going on across your entire organization. And some of the constructs that are built into Landing Zone are really, like I mentioned, the use of an AWS service called AWS Organizations. And this is a foundational part of Landing Zone that helps you to group all of your organization's accounts together. You can build a hierarchical structure of accounts and make sure that security control policies are consistently applied across these accounts. You can use organizations to aggregate cost up from child accounts to parent accounts. And then also using AWS SSO or single sign-on. So using the same identities across accounts is also an important part of enterprise organizations. They typically have one identity store, a central identity store like Active Directory or maybe Shibboleth for academic institutions, where they want to consistently use those usernames and passwords to allow people to log into their AWS resources. And so SSO helps customers to do that. And then some centralized accounts, like I mentioned, a centralized security account that's providing customers with the ability to allow their security folks to have access into every account in their organization so that they can do inspection or forensics. To have use services like Amazon Guard Duty, which is a service that uses machine learning to observe what's going on inside of every AWS account. The API calls that are being made to the AWS management console and see what are people doing inside of this account. Look at the DNS requests that they make and the network traffic and try to identify using machine learning whether or not that matches known threat patterns, and then generate alerts like through services like Amazon SNS so that you can get your security professionals real-time alerts about things that are going on inside of accounts that are a part of your organization. And then again, centralized logging. So being able to have an audit log, which is an important requirement of HIPAA, to meet the requirements, the regulatory requirements of HIPAA, but also just for the general security processes of being able to review what is going on inside of all of these accounts that are a part of my organization. Get real-time alerts from logs, whether those are from an application or from AWS itself, get an alert about what's going on inside of certain accounts. And then also have a forensic log so that you can go back and investigate, if things happen, you can go back and take a look at, well, what has happened inside of all of these accounts. So again, Landing Zone is an automated framework that helps customers to consistently build out these aspects of their environment. And so, yeah, so what that's doing is it's providing, so the AWS cloud itself combined with services that we provide and patterns that we provide like AWS Landing Zone help customers to have a solid foundation to build their enterprise organizations on, whether you're an academic medical center in healthcare or a commercial organization or any other type of large enterprise. You can use those foundations and those cloud services in order to build your Agile organization to be able to allow your developers and researchers to be most productive and also scale up to cloud scale studies and development. And I'll hand over to Jimmy to talk about how ClearScale took these, the AWS cloud and these patterns and then helped to solve UCSF's problem.
Thank you, James. I will start with a proper introduction to ClearScale. So ClearScale has been in business for over 10 years and is a distributed organization. We've completed a ton of projects, over 600, all related to AWS, and hold 7 AWS competencies. ClearScale is a premier consulting partner, one of about 30 in North America, and this is a difficult to achieve as AWS sets the bar rather high for premier consulting partner status. We've also been awarded 7 competencies in healthcare, migration, DevOps, nonprofit, data and analytics, IoT, and mobile. And to establish competency, we're basically evaluated by a third-party organization who's an expert in the relevant field and then vetted by AWS experts. We're also a member of the AWS 50 certified, which means that our staff hold a minimum of 50 certifications. And I believe we're close to the 100 mark. So what exactly does ClearScale do? Well, we have many practices, strategic consulting and architecture design services, building cloud native solutions, hybrid integrations, or cloud migration. Our foundational DevOps and automation practice. We do a lot of work with big data, IoT, ML. We develop and refactor applications. implement regulated workloads in the PCI, HIPAA, etc. And we maintain systems through our managed services team. Okay, so let's talk about our partnership with UCSF on this cloud journey. So we started with discovery and requirements gathering, where we met with researchers, IT, the SOMTech team, security, risk, compliance, stakeholders. And we held these discovery sessions to understand really what are the opportunities, right, that Sandeep spoke of, but also organizational readiness to embark on this initiative. We helped UCSF understand this AWS shared responsibility model that James spoke about and pulled together a strategy to achieve their goals. We walked through the NIST framework together because we use that as a baseline for compliant environments. And we populated a cloud controls matrix, right, that is mapped clearly to HIPAA controls. And these controls cover both technical controls, processes, and organizational policies. We were able to present the strategy to all the stakeholders, and this was a key to moving forward to implementation. We really need to get an understanding of the new methods of doing things to allow us to deploy rapidly and create environments on the fly that have quote unquote pre-approval as far as compliance goes. So in summary of the requirements, the landing zone needed to provide secure system access, centralized controls, enforcements of policies and standards, while enabling this rapid deployment of services. And that's a tricky combination, but the landing zone handles that very well. Okay, so I'm going to talk a little bit about the actual landing zone implementation and how it came to some of the decisions. Now, these decisions would probably be slightly different depending on the organization and structure and the functional teams involved. So I'll get right into it. As James presented earlier, the landing zone is comprised of multiple AWS accounts, each serving a specific purpose. For UCSF, we split these accounts by functional teams and responsibilities. We implemented AWS organizations to restrict user actions and available services through service control policies. So we were able to lock down services so that, for example, when we're creating project accounts, the individual teams involved in deploying services there will only be able to deploy the HIPAA services supported under the BAA between UCSF and AWS. And then as we implemented identity and access management, we integrated this with Active Directory for centralized control. Audit and compliance standards were managed through tools like CloudTrail, AWS Config. CloudTrail is logging every API call made to the AWS platform. Things such as changing a service, creating a resource, destroying a resource, and so forth. And config, AWS config allows us to create rules, for example, that enforce instance tagging. So we identify ownership of every resource. We tag it with data sensitivity. So, does this particular resource either store or transmit PHI data? That's very, very relevant in the HIPAA space, or technical controls, such as preventing a resource to be configured with open access to the internet. And at the heart of this system is automation, right? So the automation built in this landing zone gives UCSF this account vending capability. So it allows them to deploy a new environment that is integrated and compliant with all of the policies and standards that we set in the remaining portion of this landing zone. And this was the key to shortening delivery times by reducing the overall approval processes to actually vet, assess, and approve an environment for landing sensitive data. Now, just by moving to the AWS cloud, we've already achieved gains in as far as procurement of hardware and racking and stacking and cabling and those areas. So this is very, very process centric, and the gains we have for automation. And the landing zone environment creates the standards that are leveraged by the approved architecture for handling PHI data. So, out of our discussions, we created an architecture design, the processes and policies that go along with that. And we went through that with risk and compliance and got a sign off on, okay, now we understand that what this capability is and how it preserves all of these compliance controls during operations and during creation of new resources. And for my next slide here, if it'll move, there we go. Now this is like a high level diagram. A lot of the details have been removed, but I just wanted to show that the structure, right? So we have the AWS root account, what we call root account. This manages the service control policies and governance over the remaining accounts. So what users are available, are able to deploy in these accounts, what actions we want to restrict from these users, even administrative users. It's all managed through organizations and service control policies. And also within this space, we have the SSO service that allows us to federate a single user directory, in this case, Active Directory, and allow those users to log into many services, right? Both AWS and third-party UIs and applications that we've deployed to support this landing zone. And so on the left side here, we've taken and created a security account. And for UCSF, security encompasses those immutable logs, right? So CloudTrail logs, config logs, and security services. So any vulnerability scanning devices, patching utilities, the AWS Guard Duty master account is the security account because this organization is responsible for reviewing that data. We also are logging application level logs into EKK stack here. It's basically a logging stack in the security account in case any of the logs may contain PHI data. We want to protect that. And we have an operations account here in the middle. And this is that heartbeat. This is the automation centric account. We could equate this to a typical DevOps type team where they're managing all of the artifacts for deployment. You see here ECR registry, there will be code repositories in here, Amazon machine images, which is an artifact for deployment. All of these are governed in this account. And then we have additional automation services. There's Jenkins, Ansible, you name it. If it's doing some part of the automation to stand up environments, we store it in here because it is under the management and responsibility of that particular team. And on the right side here, we've created a specific access account. And this access account serves a couple of purposes, right? It allows us to have a central point where users can connect to their research environments, which is what we call project accounts or project VPCs. And also allows them to proxy through, right? We built an authentication layer here, so they can use their AWS, Active Directory account to then authenticate and run jobs in Jenkins, run automation jobs to create more resources or configure those resources. Now, the periphery, these accounts that I've just covered, these are permanent accounts that are constantly in operation. Now, the project accounts, this is the space where we gain that rapid deployment. We're able to create project accounts with resources such as instances, databases, so on, that are already connected to security scanning tools, that are already connected and enforcing that our CloudTrail logs are flowing into this immutable S3 bucket. It is enforcing the use of our approved Amazon machine images, or AMIs. And so we're able to deploy an environment that already has the compliance controls specified, which is huge. We've actually coined this as the secure envelope at UCSF. So every project account gets shoved into an envelope. It's secured, it's protected, and we can move on with research projects. We can move on with agile development of these middleware components for the EHR systems and so forth. And so, at the end of deploying this environment or this capability for UCSF, we're realizing a secure and compliant public cloud platform, right, that allows for elasticity, all of the benefits of cloud. More importantly, we have a 90x faster delivery of environments. This in turn is increasing the velocity of research and increasing application feature development for that middleware tier for the HR systems. And as a side effect, we also have greatly reduced storage costs. That wasn't one of our key goals when we started this, but it's definitely a benefit that was realized in the process. Okay. I'd like to now move on to a Q&A session to see if anybody's got questions for any of our panelists. I believe you can submit questions on the Q&A tab and just type them in. Okay, I do see one question here. After building the system, how to get the system certified or verified with HIPAA compliance? And so with that said, with HIPAA compliance, it's typical to hire a HIPAA auditor to come in and validate compliance and award that certification.
Yeah, I can also add a little bit to that. You know, as from a UCSF perspective, we have several different governance parties that look at the security and compliance related issues of any system. And so, as Jimmy was mentioning, there's a great deal of work done early on looking at everything from the NIST framework to the cloud computing architecture, I believe it's called, a model, to put together a very comprehensive security plan for the entire environment that details out you know, the overall architecture, what type of use cases we're going to run in there, what security constructs we have in place, Amazon specific tools. Some of these things are processes such as who's looking at the logs, how do we monitor the logs, how do we notify of any violations. So there's a very comprehensive security plan that we put together, and that goes through different governance committees within UCSF to take a look at this. Now, this is not just specific to HIPAA compliance. It's one of the things we look at, but from a health, you know, care systems perspective, there's a much more elaborate process that goes on to look at the security, to look at the privacy and legal perspectives. You know, you know, there was one instance where we were looking at one of the tools, I forgot what it was, you know, in the case of replicating its data against different data, you know, in different data centers, some part of that log was stored in a data center in Ireland. Now that's perfectly okay in a lot of the instances because you're trying to, you know, have security or protection against, you know, data center specific failures or disaster recovery. But something like that, even which would be totally, I guess, innocent in some cases, we went through a lot of trouble looking at, hey, what does that mean for as far as governance rules? So that's just an example of the level of detail these things get looked at. And so we had to go through all that process, got feedback from different governance committees, took care of a lot of the feedback issues, and that's how the system was cleared, at least internally, to support use cases.
Awesome. Okay, I see a question here from Michael. This is a proprietary structure for UCSF. However, is there a similar set of CloudFormation scripts or something similar to baseline, something like this? Or is this something that AWS Landing Zone, AVM, is capable of bootstrapping? So there is a set of CloudFormation scripts that will set up a default landing zone. And it may be useful just as is because all the services will be deployed and you know, most of these compliance related controls are present there. Again, you'll have to go through and figure out, you know, what things are you handling via processes versus technological controls. But they have, you know, a landing zone template that can be deployed and used right out of the box. The reason that this was customized and structured the way that it was is based on the UCSF organization and where they draw their lines for responsibilities of certain things.
Hey, Michael, this is James. I'll also add on a little bit to that. We do provide a reference architecture for HIPAA from AWS that does include a CloudFormation template. I pasted a link to it in the chat. There's a CloudFormation template that will set up a kind of templated environment for, it's meant to be a general purpose environment that helps to conform to the standards of HIPAA. And it also provides a spreadsheet of all the HIPAA controls, the security and privacy controls specifically, and how they map to the different technical configurations in that CloudFormation template deployed environment. So it has things like config rules and SNS notifications, some of the things that you heard Jimmy talk about that they integrated in with the landing zone automation. So that could be helpful as well.
I should also add that UCSF is a public institution. It's a public university, so we're all about advancing knowledge for the betterment of public. So I'm sure if anybody wants the architecture to be used in a public-facing context, all of our learnings are our team will be more than happy to share. So it's not as proprietary as, say a private institution putting together a system for their, specific corporate uses. This is something done at a public university, and we would like to share the knowledge as much as possible.
All right. Anybody else thinking about some questions? Remember, every question is valid. There are no dumb questions. Oh, nice. What's next for UCSF's AWS journey?
Oh, well, there's still a lot of stuff. So the first thing for us was to just make sure that this is doable and and um, and something that we can present to our UCSF researchers to use. So we got into production as of last year and started with a number of pilot projects. From those, we have learned a lot. So at a very high level, when we created this environment, we had named very specific use cases on what type of research projects we can support in this environment. So wasn't like an open, hey, you can do any type of project. So there were some constraints we put there. As we have done these pilot projects and gotten feedback from our users community, which has been overwhelmingly positive, there's a number of things that stand out. So one is obviously the users want a easier process to start, because a lot of our researchers, believe it or not, we're not as familiar with the AWS environment. So we're trying to figure out, like, how do we, is it training? Is it something else? Is it something easier we can make in terms of the onboarding process, so that's an easier start. So that's one thing. Second is, we haven't really turned on each of the Amazon's HIPAA services within our environment. Only a select number of those services have been turned on, and that's for a reason, because each service that we turn on, we have to sort of validate that service through our governance process to make sure that the service is okay. So instead of turning everything on, which we were very particular about what we're going to choose. So obviously, as people use the environment, they're saying, well, what about Glacier, or what about EMR, or what about Lambda, what about Kubernetes-based structures, and so we're getting a laundry list of things that people would like to see. So we're prioritizing this list, and then going and working with our security and compliance and privacy teams to make sure that we can turn those services on. So that's pretty big. So I think over time, what we're going to see is a number of these services being turned on. There's also a great deal of interest in a hybrid model, where researchers would like to use a hybrid of systems, some which are located on premise and some which are located on cloud. So if you can imagine any research being done with, let's say, imaging data, that's a huge data set that folks might be wary about moving all of that to the cloud. So could there be a structure where the imaging data is stored on premise in UCSF and the computing happens on AWS on demand? There's stuff like that, like a hybrid or a cloud bursting type of model. That's another. And then the one area which you probably caught in the presentation as well, we said there are like two key business problems. One is around the clinical labs, and one's around research computing. We've only looked at the research computing use case as of right now. the whole area about, what does it mean to have clinical apps on the cloud? That's another big question that we're trying to answer. And that's not just us at SomTech. There's various sort of groups within UCSF looking at that and looking at cloud very seriously to make that happen. So those are like the number of top initiatives, if you will, that we're looking at right now in terms of our cloud or AWS journey.
Okay, looks like we have a couple of other questions. We got 5 more minutes. I think we can get to these. So in regards to AWS charges, how does one go about estimating the costs? The AWS online estimator has been found not to be user-friendly. How are the costs calculated? Primarily, that's a tool that we use for calculating costs. For a larger infrastructure, we will bring in a tool, because I know that the part that's not as user-friendly is figuring out, this is what I'm running in my data center or a different cloud or wherever, and mapping those to appropriate resources in AWS. And this we usually do by hand for smaller environments. If the environment has significant number of servers or resources, we'd prefer to use a tool. There's quite a few out there. I know at AWS we've worked on projects where we've used TSO Logic, a product called Cloud Chomp as well, to kind of run these estimations.
Yeah, Victoria, this is James. I'll agree with Jimmy that there are other good tools out there. The ones that Jimmy mentioned, I've heard positive things from our customers about as well. And then you always have your AWS account team. Also at higher ed universities, you can reach out, and solutions architects would be happy to help you estimate the cost of a solution, especially if it's particularly complicated or it involves scaling or things like that. And partners as well. I'm sure ClearScale would be happy to help you estimate the cost of a solution also. But specifically, you can reach out to me if you like.
Great. All right, and then Julia has a question. Do they share best practices with other public institutions? If so, how do they accomplish this?
Yeah, so I could take this one. So there's a number of ways we do this. So one main one is called UC Tech. It's a annual conference where we do a round robin of various different UCs host this conference for everybody who's involved in technology or interested in technologies at the UC. So last year it was at Davis. This year it's at Santa Barbara. And so that's our probably one of the best forums where in person folks present a lot. I know we at SomTech have presented a lot on this particular project, last year's conference, and also on this year's conference. And obviously there's other UCs that have their own initiatives around AWS that they share. That's like a more formal forum. We also have a Slack group called UC Tech as well. And there's a very active and lively forum for AWS where people talk about all sorts of nitty-gritty and gory details of AWS related stuff. So pretty lively discussion going on there. So it's a very, and of course on sites, I know that we've done several presentations at UC San Francisco, also at Berkeley, where there's a lot of cross-pollination and folks almost know each other because we're all in the same boat of trying to make AWS work within the constraints of the UC's policies and technology constraints and so forth. So those are some of the venues. So if you're affiliated with the UCSF UC system, I would definitely encourage you to look into UC Tech and also the Slack channel. Those are the main methods we have right now for sharing best practices.
Okay, so just about 12 o'clock now. We're going to wrap things up, and you guys can reach out to us If you have any additional questions or something comes up later that you think about, feel free. We will also send out a recording of this session to all attendees. So thank you all for joining. I know everybody's got a busy day, and then we'll let you get back to the task at hand.
Thanks, everybody.